This will be a lesson to you. You try and be cheap, you're going to do it twice, and it's going to cost you twice as much. Okay? Okay. It's the same physical size as those, but those are, I think, 1 or 2 grades less precise, which means, how much preload you put on them, you always had like 6 to 7 thousandths of play in the spindle. And I forget how much run out it had, but not a good amount. So I went and bought the proper ones for $375 instead of the cheap ones for, I think I paid $80 for those. So if you try and be cheap, you're going to spend twice as much, and you're going to do it twice. Like, this medicine cost me twice in parts, it's cost me twice in time, and it was just lost time. I could have been doing something else. Their marketing is hilarious. You've purchased some of the finest precision machine bearings available anywhere in the world. I can't read very well. Some of the finest. Why aren't they the finest? Now I'm disappointed in you. I wanted the finest bearings. Just a quick lesson, and don't cheap out. It ends up costing you more later on. I don't know if you can hear me or not, but that greasy old Bridgeport right there just drilled a lot of holes tonight, and I've built spills tonight. It ain't been half bad. I don't know if it was made for running a hole saw through a piece of 3-inch Schedule 40 though. I don't rightly know. A quick way to locate on a mill. Note, not super precise work I'm doing here. This could apply to super precise work. Does not. My holes line up. The ends do not. They're just bandsaw cut with the porta band. So, if you're watching this, you've likely, need to scroll over, in this case, 6 inches or several inches or whatever it may be, on a mill. I do not have a DRO, as y'all can see. So say I'm, just casually spinning the dial. I've lost count how many times it's gone around. There's a mill. Why bother trying to keep count? I know I'm going 6 inches. So there's 30 revolutions of this dial. Okay, wonderful. Each revolution is 200 thousandths of an inch. So what I can do, I can take a measuring tape or a ruler, and I can line this up until I get close. So I know from this point to this point is approximately 6 inches. I set my dial at 0 here. So I know if I take this and I dial it back to 0, and this measuring tape, this crude measuring device, reads approximately 6, then I have turned that dial 30 times. And I am where I want to be. I am now 6 inches to within a few thousandths, however accurate my ball screws are, of where I need to be. And that's just a quick way of checking yourself and not having to count revolutions of a dial to move a large distance on a mill. A ruler or whatever works easier. A trick you can do to make this really easy, if you have this, and I have stops on mine for going back and forth between 2 positions quickly. I just kind of bump into this. Just take a ruler, in my case a 42-inch ruler, and rivet or screw to this that lines up with that witness mark. That makes it really quick and easy. No tape or ruler. And you can do the same on here. I prefer to have it line up with that seam right there. I'm yet to put one on this mill. So for DRO, well, this is a great substitute for DRO, and it is cheap, and you can easily do it on all 3 axes. It's not as accurate, give or take a couple thousandths of an inch. I mean, you're relying on your dials, and it's a little bit more thought than DRO. It doesn't count the whole inch for you. It just gets you close to 200 thousandths, and then your dial takes over from there. And you have to zero it with your dial, so you may have, you're doing a bit of mental math between your inches here. But great substitute for DRO if you are too cheap to buy one like me.